Hello, everyone. I hope you are sliding into the weekend already. It is Friday at about 2:15 p.m. And I just wanted to make a really short video to give you a hint on a computation that you probably need multiple times on the current homework. So this was something I was just about to get to in class on Wednesday when I ran out of time. And I didn't feel like I should really cancel. I would have to cancel quite a bit of the homework. So it's about expectations for the exponential random variable conditional on being above a number or below a number. So let's suppose that we have t exponential with rate lambda. We know, of course, that the expected value of t is 1 over lambda. But we're going to look at like some constant. So I'm going to let c greater than 0 be a constant. And there are two expectations that are going to start coming up for us over and over again, starting now. So one of them is the expected value of t given t is greater than c. This is what I call the easy one because we can use lack of memory. So if you imagine a number line, now this is not necessarily an inter-arrival time. I'm not talking about any sort of particular process. But if you imagine a number line on which to like graph this t, it might be over here, or it might be over here, or wherever, it's going to be somewhere in relation to a fixed c. So I'm going to put c down. And if t is up here, what is this expected value? We want the expected value of this entire piece, and that is made up of this piece. So we have c units of time, and then the expected value of the remaining piece. But by lack of memory property of the exponential, this remaining piece is exponential with rate lambda. So this is just another expected value of t. If you want to call it r for a remainder, that's okay. It's not, this is t. And so I wouldn't call this t, but they have the same distribution. So if you're using that within a probability or expectation, you could use the same letters. And just to finish this off, this is c plus 1 over lambda. So it's the reverse of this that is trickier. Let's look at that. The expected value of t given that t is less than or equal to some c. And I've got two ways I want to mention for you to do this today. The first is going to be to find the conditional PDF and integrate. So I'm going to integrate over whatever the space is, t times the PDF for t given t less than or equal to c, t dt. This is a weird looking thing. Up until now, we've only seen conditional PDFs for two random variables written like this. You'll notice I only have one variable up here because there's only one random variable involved in this PDF. It's just conditioned on something happening. The formal way to find this PDF, I would write out the CDF and then use the definition of conditional probability and go. But I'm just going to talk about it with pictures. So the exponential rate lambda PDF, which is the PDF for t, starts at lambda and then goes down exponentially. It doesn't look exponential, but good enough. And we have a fixed c, and we know that we have to be in here. So basically, this part is ruled out, and we are talking about a PDF that looks like this. Now, if this curve is lambda e to the minus lambda t, let's make this the t-axis, well, it's not because we cut some of it off. And what's left is not going to integrate to 1. So we need to normalize this. We need to compute the total area in here and then put that underneath the PDF so that what's left will integrate to 1. In other words, if this integrates to 1/3 and you put a 3 in front of the PDF, you've now made a PDF that integrates to 1. So the total area here is the CDF, and that is 1 minus e to the minus lambda c. It's the CDF up to C. So the PDF for t, given t is less than or equal to c, is lambda e to the minus lambda t divided by 1 minus e to the minus lambda c. And that holds for all t between 0 and c. So there's the PDF you need to use to do this calculation. Again, if you want a more formal approach, I would start with the CDF for t, given t is less than or equal to c, and write that out. So you should end up with the same thing. Now, I did say I had two methods for you, and this is not the second method. The second method is kind of fun and slick. So again, I want to find, by the way, I didn't do the expectation, right? So you need to take the PDF that's in this wavy circle and put it up here. And the integral will go from 0 to c. And you can't get away with that integrating without integrating trick because we don't have a PDF that looks like this that lives on a finite interval. So you'll actually have to integrate. But my other trick was this. So I want to find the expected value of t given t is less than or equal to c. Check this out. We can write the expected value of t as the expected value of t given t is less than or equal to c times the probability that t is less than or equal to c plus the expected value of t given t is greater than c times the probability that t is greater than c. We know a lot of these things. This is what we want to find. And I think we know everything else. On the left side, the expected value of t is 1 over lambda. This in here is the CDF for t evaluated at c. So this is 1 minus e to the minus lambda c. Over here, this is the tail probability, so it's 1 minus what I just wrote down. This is e to the minus lambda c. And so we need to find this, and then we can solve for the thing in the yellow box. Well, we did this one earlier. This was the expected value of an exponential, given that it's greater than c, and so that's going to be c plus the remainder, which is still exponential. So another expected value of t. And that's going to be c plus 1 over lambda. So we have all the pieces. 1 over lambda is the thing we're trying to find. And that is multiplied by 1 minus e to the minus lambda c. And to that, I'm adding c plus 1 over lambda, e to the minus lambda c. And you can solve for this. So again, I think you're going to use this multiple times in homework 6, this expression. So just do it once, and let's put it behind us. Next time on Markov chains.